everyone. Today is another class or another topic of physics. This class is for grade 11. In this class we will cover a new topic, which is static electricity. So our presentation today, our class, will consist of or contains 5 main parts. First part is what is charging and discharging. Number 2, electric fields. Number 3 is friction and charging, and charging by induction. So we have 2 ways to do charging, by friction and by induction, and we will show some experiment to do that. Number 5, representing an electrical field. 6 is a summary of all those topics and subtopics. So first we will start with charging and discharging. Actually, we experience static electricity in a number of ways in everyday life. For example, number of ways in everyday life. You can watch what electricity of static or static of electricity. How? For example, you may notice that when tennis sparks, or may have noticed tennis sparks when taking off clothes made of some material of fibers. Another example is, so you can say that when you're taking off your clothes, you will say like a thin spark, especially in winter. Thin spark, because of what? Especially for clothes especially for clothes made of what? Of fibers. Example number 2 is, you may have felt a small shock when getting out of a car. When you're trying to get out of your car, so you will feel like getting some shock from the door, the door of the car. So an electric or electrostatic charge, this is happened because of what? Because electrostatic charge builds up on the car, and then this charges through your or through your body when you touch the metal door. You have probably rubbed a balloon on your clothes, on hair, and seen how it stick to wall or ceiling. So different types or examples or a lots of phenomena of what to experience static electricity. The charging and discharging. As we can see here in this figure, there are some charges or charged objects affect one another. So all of charged objects could affect each other. Here in this figure, figure number 2, shows one way of investigating this. How? When you put like a plastic rod and then rub it with a cloth, so that both become charged. Both of them, they become charged. Here, this is the cloth here, this is the cloth here, and this is what? The rod here. When you rub them together, so both of them, they get charged. The rod is, as we can see here in this figure, the rod is hanging a cardle, so that it's freely to move, suspended to freely move, and or it's free to move. So when cloth is brought close to it, when you brought this cloth close to it here, so the rod moves towards the cloth, which is described in figure A, 17A. For second one, if a second rod is rubbed in the same way and brought close to the first one, so the hanging rod moves away. Why? It moves away here, as we can see in figure B. So we have two different cases here. In this case here, they are comes close to each other. When you rub it with the cloth, they comes to each other. And then when you rub it here, the rod is rubbed in the same way, and the brought to close here, they get the same what? The same electricity, the same charge here. Here is different charge, that's why they comes to each other. Here they get the same different charge here, so they are repeat each other. And here they are the same charge, that's why repeat each other. So this one is start moving where? This way. It start moving this way. Okay. So this is happened because of what? There are two types of static electricity. There are two types, as we can see here in figure in C and D, which represented where the above one. This one is represented this one. We said this those ones clothes and the material here, they are attract each other because of what? Because they have different charges. This one is positive and this one is negative. So the force here is attraction. There's attraction between both of them. Here they got the same charge. Here. So this one is negative charge and this one is negative charge. So the force here is what? Repulsion. This repulsion force. So there are two types of static electricity, are referred to as positive charge and negative charge. So we have two types of a charging or charging material. They are positive and negative. So we can explain experiment in figure 17.2 by saying that the process of rubbing gives the rods one type of electric charge. Say negative. It could be negative, it could be positive, but one type of charge, one type, positive or negative. Let us say negative charge. Why the cloth is giving the opposite type? Say what? If we take this one is negative, so this one let us say positive. So in C here, in figure C and D show two experiments which the charges marked with the charged markers. So this one is positive minus force of attraction minus force of repulsion. So the conclusion is what? Like charges repel each other, unlike charges attract each other. So like charges repel each other, like here, like for example negative or positive. They repel each other. Unlike charges attract each other, for example positive minus or minus positive. So the force here, there's a force here and the force here. The force here is attraction, the force here is repulsion. So the conclusion that there are two static or two type of static electricity which they are positive charge and negative charge. Okay, now so there is an, as we said, there is a force here and the force here. So now let us move to the another subtopic, which is electric fields. As we said in the last figure, a charged object, any charged object can affect other objects. How? Both charged and uncharged. So any object, charged object, can affect what? A charged and uncharged what? Other objects near to this one. So even have a charge or no charge can be affected what? By charged object. So without actually touching them, even if you put it close to each other here, as we say in the last figure, they put the cloths near to the rod, so they are affect each other without touching, actually touching them. So for example, a charged plastic rod can exert a force, as we said in the last figure, force on what? Another charged rod placed close by. There's an effect from where? From plastic rod to what? By what? By the another rod or by the cloths. So we say that there, the conclusion is we can say that there is an electric field around a charged object. Any charged object, there is an what? A field. So there is as a magnet, as we said before, there's a magnet here, for example in S ball. So there's what? There is a field here around where this magnet, it's here. Even for any object, charged object, positive, negative charge, there is an what? Electric field. So this field experience any charged object placed in the field here near to this one will experience a force on it. This force, as we said in the last figure, it could be repulsion or it could be attraction. It could be repulsion or attraction force. Okay, now we can get charging any object. It could be charged by, for example, two ways. We will discuss two ways of charging: friction and induction. We will discuss charging by induction and charging by what? Friction. So first one is the friction, and how we can use the friction to get a charging or a charging by friction. Actually, when plastic rod is rubbed on a cloth, so there is a force of friction that causing a charging. So it's the force of friction that causes what? Charging when a plastic rod is rubbed on cloth. So friction transfers what? The process of friction here. What happens here with the friction? Actually, friction transfers tiny particles called what? Electrons. Electrons is what? Negative charge. It is negative. From one material to the other. It comes from where? So the friction is a process of transfers tiny particles called electrons from one material to the other. If the rod is made, for example, for polyethylene, it's usually the case that electrons are rubbed off the cloth and into the rod. It depends on the other side or other material. So friction is what? It's the force of friction causes what? Charging. Friction, it causes what? A charging. How? By transfer tiny particles cause what? Electron from one material to the other. Okay. So electrons are a part of what? Every atom. Electrons, as we discussed before, it's a part and moving where? Around the center here. There's a proton, neutron here, and electrons moving where? Here. So electrons are apart from what? It's apart from any atom. And they are negatively charged. They are always negative. And they are found on the outside of where? The atom here. It's moving where? Outside of the atom. Since they are relatively weakly held in the atom, so it's very weak to hold where? To the atom compared to the proton and the neutron. Since they are relatively weakly held in the atom, they can be readily pulled away from where? By the force of a friction. So it's easy to get them where? Away from the atom here to the other object by the process called what? Friction. So friction is the process of taking electrons from an atom to the other object, or any material. An atom has no electric charge. Atom has no electric charge, so we say that it's what? Natural. It's not positive, not negative. When an atom has lot of electron, it becomes positive what? Charged. So it could be positive, it could be minus. Minus or positive charge or natural charge. Okay, now the second one is charging by induction. We discussed the charging by friction. Now we are going to discuss charging by induction. A charging object can attract uncharged objects. Any charged object can attract uncharged objects. For example, say in this figure here, it's got some tiny pieces of paper on the bench, and then rub a polyethylene rod on a woolen cloth, and then both charged rod and the charged cloth will attract the paper. If you put some teeny pieces of paper on the bench, like here in this figure, and then what we'll do, just try to rub a polyethylene rod on a woolen cloth, as in this figure. So both the charged rod and the charged cloth will attract the papers. Actually, this is the same effect as what rubbing a balloon in your clothes and sticking it to a wall. What happens here? Uncharged object or uncharged object, for example here in this example, this is the wall, is attracted by charged one, which is the balloon here. So how does this happen? How does this happen here? As we can see here, this is the wall here, and this is the air. So there are a positive and minus charged here. When you put something is positive here, so the positive ones on the wall, they will be moved this way, and the minus one will move this way. So they gonna attract each other, same as here. So the positive on the balloon and the wall will attract all, say, the minus one, and the positive, they will be moved this way. Most electrons, positive charged will move this way, and negative charged will move this way. But the question is, how does this happen? For next slide here, we'll explain how it could happen. Suppose the balloon has a positive charge, as we say in last one here in the last figure. The balloon is positive charge. It must be attracted to what? Negative charge in the wall. So negative one will be attracted to what? To the balloon, because the balloon is positive. If the balloon is negative, so the negative one, they attracted to what? To the balloon. So the wall itself is what? Natural, uncharged, but its atoms are made up of what? Positive and negative charges. So when balloon is brought close to the wall, its negative charges, electrons, move to where? Towards the balloon, because they are attracted by it, which explained in figure 17 for section B, or here in this one. Actually, they may not move very far, but the effect is enough to give the surface of the wall a negative charge, which attracts the balloon, as we discussed in figure C. So we say that a negative charge has been induced on what? On wall. This process is known as charging by induction. This process here is known as a charging by induction. So there are two ways of charging by friction and charging by induction. Here is the example. So this is the what do you call charges on the wall. There are positive and minus what charges. It comes from where? From the atom itself, because there are positive, which are proton, and minus, which are electrons. If you put something positive near to it, so the positive here will attract the positive, the minus, sorry, electrons. If you put negative here, so they're gonna attract what? The positive ones, and repel the minus one. So now we are going to discuss how we could representing an electric field. As we said before, any charged object is surrounded by what? Electric field. If we take like proton here, so there's an electrical field like this. From where? This one. The minus one, it comes where? Inside. The positive one can move where? Toward this outside. So if we have, for example, different charged, for example, negative and positive. So the electric field is moved from the positive one to the minus one, positive to the minus, from both sides and also from the middle here. So a charged object is surrounded by what? An electric field. Here, this is the electric field. This is an electrical field. This is an electrical field of same charged. This is an electrical field of different charged. Here also is different charged. So if a charged object moves into the electric field of a charged object, it will experience what? A force. Definitely, it will experience a force. It will be attracted or repelled. So it depends on what? The kind of charge. For example, here there's an attraction. Here what? There is a force here. This force is repulsion, because this one is positive and this one is positive. If we change one, as we discussed before in last classes, if this one positive and this one is minus, so the force here is what? Attraction. It depends on what? Depends on the charged object. So it could experience a force of attracted or a force of repulsion. Here in figure 6 show how we represent an electric field by lines of force, or it could named electric field lines, in similar way to representation of magnetic field by magnetic field lines. It's the same. So what's electric charge? What is electric charge? Question like what is electric charge? We have to answer it by saying how objects with electric charge behave. Objects with the same sign, as we discussed before here, objects with the same sign of a charge repel one another. There is a force of, it's a force of what? Repulsion here. On the other hand, objects with opposite charges attract. With opposite charges, for example, positive, minus, they are attract each other. So there is a force of attraction. This is actually not a very satisfying answer, because magnetic poles behave in the same way. North poles repel north poles and attract south poles. Because electric charge is a fundamental property of matter, we have to get a feel for it rather than having a clear definition. It's not, there is not, for example, clear definition for that one. But up to here, what we will say, object with the same sign, charged of a charge repel each other, and objects opposite charge attract each other. There are two forces between them. Charged particles, as we discussed before, we have already seen that what electrons are what? The charged particles that are transferred from one object to another when they are rubbed together. So electrons, because they are weakly connected to the center of the atom, they can move away from it when they are rubbed together. So electric charge is a property of particles that make up what? Atoms. A charge is measured in what? A coulomb, as we discussed before. It's by coulomb. So an electron is negatively charged particle. Electron is negative charged. It's much smaller than what? An atom. It's much smaller than the atom and only weakly attracted where? To the outside of the atom. So it's easy to get it out from it, or they can attract it. So it's held there by what? Attraction of the positively charged of what? Of the atom, which they are proton. So the nucleus is positively charged because it contains positively charged particle called what? Proton. Protons, as we discussed before, are positive, electrons are negative. So charged particles, there are two types of charges here: negative, which is electrons; positive, which is proton. And there are neutron. Neutron have no charge, not positive, not negative. And the charge, keep in mind, charge is measured by what? Charge is measured by coulomb. So an electron, any electron, have a very tiny amount of what? Electric charge. The electron charge is so small that it takes over 6 million electrons. Say it's very, very, very small. 6 million electrons to make what? Just one coulomb of charge. So electron charge is equal to what? Minus 0.336. This 1 million, 336 is another million, and this is another million. So it consists of what? 6 million. So it's equal to what? 1.6. So it's equal to minus 1.6 times 10 to the power of what? How many zeros here? Are 19 coulomb. The same way as proton. Proton has exactly the same charge as electrons, but what? Not positive. Minus. Not negative, is positive. So proton is positive. The same. It's equal to 1.6 times 10 is the power to the power of minus 19 coulomb. It's very small amount of a charge. Protons are positive, electrons are negative charged. So now we will come to the summary of this topic.